another week. Hope we'll enjoy. Just refresh a little bit our previous story of chapter 4, where we saw a formula and also a couple of interesting observations. So there was a mean, the average that they call was letter mu for entire experiment, as well as a level of spread, the standard deviation that you could estimate, and then the formula for probability of so-called number of successes, and that was combinations to choose x out of n multiplied by probability of that success, and also multiplied by the complement of probability of success, which is failure. So this formula is what we used to do every exercise in this chapter, and that's what characterizes the statistics, the fact that you need just to know the formula and everything will be just plugged in. And that's why it's not really mathematics, because in mathematics you need to probably think about how to get to this formula, but in statistics you have the formula and plug numbers in, so that's really different skill, carefully using calculator. So I can try an exercise here. Let's say problem number 8. This is again chapter 4. I found it in the last section that we worked on, section 4.4. We do 4.3 and 4.4 sections in chapter 4. So let me write this down. Section 4.4. So in the exercise number 8, I will be looking for the probability to find the left-handed people. So it says that 10% for P probability, P, always P, as 10%, that will enable me to right away find the complement of not left-handed person, so that'd be remaining 90% according to information given here. And then the next sentence says 25 students, so that's number of people or sample size. So that's the only skill you really need for this, because what we do is just identify the numbers, what letters they correspond to, so we can put them in the formula. So now they ask about mean and the standard deviation. Okay, so we need to know what mu and what sigma are going to be equal to. So we need to be able to realize the names, the formulas that we need to use. And well, not many formulas in this section, actually 2 of them. And right away, we're going to plug numbers in. 25 for n, which is multiplied by 0.1, 10% for p, so that's 2.5. And you say 2.5% left-handed? Well, realistically between 2 and 3, but it may be a little bit less or a little bit more, depends on the level of standard deviation. So since I already have q found, I'm going to multiply it and then put inside the square root, right? So let's go for the favorite calculator. I have here scientific calculator, was what we did last time, is still here, so I can continue using it. So square root 25 times 0.1 times 0.9. 1.5. Okay, 1.5. When I was able to find mean and standard deviation, now we can actually see what we expect. We expect always the average, but we can try to make a little sense out of all that. So part A of the exercise is done. Now part B in here, it says, would it be unusual to find that 5 students are left-handed? Well, let's check this out. Our mean is in the center. It is 2.5. I say, is that 2 or 3? Well, let me use standard deviation of 1.5 first to see the left and right ends of my ballpark. So if I add 1.5 and 2.5, we'll get exactly 4. And if I subtract 1.5 from 2.5, we'll get exactly to 1. So now it starts to make sense to see the number of people because, of course, there's just a whole number possible, either 1 or 2 or 3 or 4, right? Let's say Alex, or 0, yeah, could be no left-handed people, or 5, could be 5 left-handed people, could be 6, could be 7, could be 8. Please notice the more we consider, the farther away we're going from the ballpark. So the farther we are, the less likely that you're going to find so many left-handed people, but 4 is very likely, 3, 2, 1. What about 5? They ask about 5. Is that likely? It is possible, but the chances of that are not very high. In fact, what I can do is calculate probability of that. So I can find P of 5 by using the formula from previous section to see what's the chances that we're gonna find so many left-handed people. Let's say how many? Well, 5. So what if X is 5 in the 25 persons sample? So I go combinations, 25 choose 5. I already have N is 5, X is 5. That's what they care about because they want to find that. Well, let's multiply by P and Q now. So I need to go with P, which is 0.1, Q, which is 0.9. So 0.1 raised to the power of 5 and 0.9 raised to the power of 25 minus 5. The formula from previous section is being used here to get the exact answer, make them happy. So let's do that. Functions, remember, combinations. Back to the menu and put what we need here, 25, 5 times 0.1 power of 5, right? And then down times 0.9 raised to the power of 25 minus 5. 25 minus 5 is 20. So Alex, looks like you wrote that 25 minus. So here's the chance that you're gonna see 5 exactly left-handed people is about 6%. Low chance in a class of 25.
Excuse me, Professor, you said 25 minus 9?
Yeah, that's what I supposed to put here. 25 minus 5.
And is it 20?
20. Yes. 20. 25 minus 5 is 20.
Isn't it 16?
25 minus 5. 25 minus 9 is 16. That's right, but I miswrote. I'm really, really sorry. I have no excuse for that because I said subtract 5 but wrote 9. I need to go there again and double check what's with the wires. It's something in my head, I guess, is not really connected properly when I say one thing 5 and put down 9. There is no reason for me to put 9 because it must be 5. 5, 25, 5 is 20. But thank you so much for noticing. That's nice, nice. So 20, right? Power is 20.
Yeah, now it's correct. Yeah.
So it is 6%. And when you say 6.459, and yeah, so we say it's about 6%, a little bit higher than that, but it is still not large enough to say that we will expect this to happen. It may, 6%, it's low, but it may happen 6%, especially if you would repeat this experiment again and again and again. In every class, you might find 6 left-handed people eventually, but 6% means 6% of classes that you're gonna study will have this low number of left-handed people because you expect to get less. You expect to get 4 or 3 or 2 or 1. In fact, you can use the same formula to calculate the chances to find 4 people exactly, or 3 or 2. Probably 3 or 2 is very likely, so it's going to be much higher chance than to find 4. But when you go to 5, or if you go farther, you could also calculate the chances to find 6 left-handed people, or even more than that. There'll still be some little chance, but we say no chance because probability looks like going to be less than 5%. So we say that if lower than 5%, it's unlikely. Unlikely. And if it's less than 1%, well, that's not going to happen. That's just extremely low. It is possible, but if you keep doing it all day long, then eventually you will encounter such a situation. But in 99% chances, it's not going to happen. So we say not. We don't expect that. So I guess this not precise portion of things happen or not happen takes us a little bit away from math, which is perfect world where we say everything we know for sure or not, but to get to the real world where things may happen, but usually such a low probability it's not. And that's what statistics is trying to do, to teach us to make a transition from math to the real life, which is interesting to think about because it is really very applicable for a part of the story that we encounter in. And I guess that's great that now we can see where mathematics is really being utilized to daily base stories. And Poisson distribution I skip because we go to the normal distribution. Turns out on the planet of Earth, everything is distributed normally. And that's why we learn this normal distribution. And they say the picture of normal distribution is here, a so-called bell-shaped curve. In fact, sometimes students say, Alex, are you gonna grade us on the curve? Well, the curve means bell-shaped curve or a normal distribution, and that's what this is actually about. So some people hear the word curve but don't know what this is. So it turns out the curve is normal distribution, so it's about that many C's, and then same as many B's, and then the rest very low number of A's. So on the curve is something you don't want you to be graded on, because most students should get C's and then less B's and only few A's. So that's how this should look like if you're grading on the curve. So no matter if student gets everything done correctly, but because I grade on the curve, I cannot give A only to 2 or 3 students in class, and B should be like 10 students and 20. Actually, I didn't put it correctly, because the lower part is not A or B, the lower part is D and F, right? The grades are not just A and B. The grades are also some D's and some failing grades. I'm not sure why I put that, but here now it makes sense. So same as many F's as A's, same as many D's as B's, and most grades are C's. So that's normal distribution, the normal curve. Well, again, that's not fair grading, because some students might be very good and very strong class, so there should be better grades. And in some cases, there should be very weak class, and maybe some of those A's or B's should actually be C's or even D's in the previous class. So that's why it's not really a good idea. But the practice shows that in some places it's actually standard grade on the curve. So anyways, normal curve, I would say pretty much everything, 99.9% of everything is graded, it's distributed normally. So what does that mean? Well, everything pretty much is normal distribution, and to get it studied, people design so-called standard normal distribution. Standard normal is something that we're gonna start this chapter with, and I'm gonna need to clean this mess first. So I'm gonna stop sharing it, and then I'm gonna share this again. And that's the fast way to clean the screen. So the name distribution is being deserved by that bell-shaped, it's like a bell, right? It's bell-shaped curve, because the area under the curve is equal to 1. Turns out that's the key feature of any curve that's called distribution. So the area under the curve is 1. And areas under the curve, if anybody ever encountered so-called calculus process in mathematics, calculus classes, they find areas under the curve, which is integral, and that's not what we're doing in this class, so please don't worry. But we're using the results from calculus calculations for these curves, and they also discuss the fact that mean and standard deviation of these curves that all have areas equal to 1 under them, and the red and the blue, that's why they call distribution. The mean may be smaller, like for women, I guess that's heights. Women heights turns out have tendency to be a little less than men's height, they say, and the height for men is a little bit bigger, 69, and height for women is a little lower, 63.6. And the standard deviation, the level of spread, right, how wide this distribution is. So some of them may be wider, some of them may be little bit narrower, but what we do is we start with studying standard normal distribution. It has its special actual or standard because mean for it is 0 and the standard deviation for it is equal to 1. Turns out that once we get information about standard normal distribution, then we can convert this standard normal to any normal distribution whatsoever. And that's convenience given to us by calculus, and we will discuss this today. So standard normal distribution, they say, is the one that has mean equal to 0 and standard deviation equal to 1. One can say, but that's not realistic in the real life. Mean and standard deviation are all kinds of numbers, definitely not 0 and 1. Yes, as I said, next time on Wednesday, we'll see how we can transition from standard deviation, from standard normal distribution to any normal distribution whatsoever. And that will be convenience using statistics results to just about anything in the real world, to 99.9% of all populations possible, which is very powerful if you start to think about it. So they here have a nice discussions of this, but the point of story is how to find various areas. So they say area under the curve, which is the same exact as probability. So area is the same as probability. And probability also has the same rule. Remember that probability is always in between 0 and 1 for any event whatsoever. Call it as A. It is varying from 0 to 1. And it may be even equal to 0 or 1 or 100%. Maximum is here. So that's why they relate it to area. And the way they do it is they get so-called tables, because in calculus they actually use integrals, but since we don't learn integrations, we get ready results. And I will show you how to get to free tables. The word free is great. I like that, and I'm sure everybody prefers it. So if you want to find, for example, area from number -2, so it turns out the 0 is mean, and mean is always in the center, the average. That's what I expect. It's highest chance, highest probability, so it should be in the center. And if they have the value, they call it as not x, but z is equal to -2. So they're wondering about the area to the left from that -2. And they like to call it as -2.0 or 0.00, so they can attach as many zeros as they like after that point, because it makes no difference. You just put 0, 0, 0, 0, 0. I say, why would they do that? Well, to use tables. So now I'm going to show you how you can get the free tables on Google. So if you open the next window and go to the Triola, that's the name of the author that I'm using, tables. So I start typing your tables. So Mario Triola is the author of the textbook, and I want to use Triola tables. Not sure why they put that. This whatever Triola. I need Triola's tables. I guess AI. See, AI has no brain. It's artificial, so it throws on you some stuff you don't even ask for. I'm not sure what this is. So Oh, tables. Maybe. So looks like we have, see, it's found something. So it gives me tables. Actually, no, I don't need tables. I need the one that looks not like the one that you use, the furniture. So through all the tables, so I can click on choice 2 and it will open a nice attachment to this textbook. If you buy the textbook, it will be like insert inside the textbook. But since we don't buy it, I don't think there is an insert provided in the link that I gave you, but it's always available for free online. So choice 2 if I go on Google. If you use some other search engine, then maybe choice 1. It's very popular by Mario Triola because he's world-known author. So here they have first page with formulas. Formulas we don't need, but you can see some formulas that we already learned in chapters 3 and 4. And now chapter 5, we're in chapter 5, so you just skip all these formulas and you move to page number 5, I believe here. So it says negative z-scores. So it turns out that instead of x-axis, to identify the fact that we're here using so-called normal distribution, they call it a z-axis to make sure everybody realizes that we're dealing with this normal distribution. So this is axis called z. So various so-called not X scores, but Z scores is what we are going to use here. And in order to find a Z score for negative 2.00, first of all, I'm going to need to identify the place of hundreds. That's why I attached extra zeros here, so I can find the column with hundreds in it. So 0 hundreds, 1 hundreds, 2, 3, all the way up to 9 hundreds. It's hundreds. And then the row will correspond to negative 2.0. So that's place of tens. And we also have 0 tens, so it's minus 2.0 is where I need to find on the intersection of the row and the column. Just like here, we have intersection. Like a battleship, right? Battleship game. So you have a row and a column. And right there, we get the answer for the area from negative 2 to the left, which is 0, 2, 2, 8. So this is going to be my area, which is the same that people call probability, that Z is to the left or less than negative 2.0 or negative 2 only. Or if you want, you can put it as minus 2.0000, whatever zeros you like. But just minus 2 is good enough. And I can go back to the textbook and see they also have the same answer here, minus 2.0228. So exactly the same that we just found in the little tables. So today's goal is to practice to use these tables, and to do practice, I can go to the end of the section 5.2. Again, 5.1, we skip, just like we skip every first section of this textbook, because every section introduction just tells you what's going to be in the entire chapter 5 and does not have any exercises. So I do exercises for 5.2, or 6.2 or 7.2, whatever, not in section 1, section 2, 3, and so forth. So anyways, we can see there are lots of analogous questions. They just designed to practice. So start at problem 9 through 28. I will pick a few of them and use tables to do it. And maybe next time I'll give you a little quiz. So today I know it's too much, and Monday, right? So we'll practice together, and then next time we'll try it as a little quiz as well, because I know we didn't have a quiz for a while. So tables in the middle of this Triolos page. So what I can do now is I can just copy and paste this link to chat. So let me do that. So go to chat, and I'm gonna paste this Zoom. So now I also need to make sure I get rid of this extension, because I have a Acrobat downloaded to my computer, which is a free computer from the college. You can also get the free computer from the college. Did you know that? You just need to fill the application form in IT, and they usually let you borrow the free computer. And the advantage of that is it has a free Acrobat reader and the Microsoft Word, entire Microsoft Office, and it's you don't need to pay for those programs. I'm sure you know you have a computer, but or laptop or cell phone, but it may not have those softwares such as Microsoft Office and so forth. So that's why I always recommend my students to try to borrow a computer at the college, because they provide a free service for those expensive programs, so you can use them while you're taking classes. So anyways, so here's a link here, so you can find it in the chat I just shared with everyone. So you can click on it, or else you could just in Google search do Triola tables, and choice 2 that you click on. It's totally free, no obligations, no need to push your email so you get some annoying things, or credit card that will be charged every week. My son put a credit card in the Google, and I noticed that my credit card was charged $5 something every week for the last few years already, and I was not checking the credit card statements for something that he never used. He's only 7 years old, so he just clicked on something a while ago, long time ago, and well, they like to charge you, but you don't even know that they charge you. So it's very fair, very fair. That's how those companies become very rich, because they charge people without their knowledge. Well, not the only why, but one of the reasons as well. But anyways, so a row and a column, and that's the whole point. And the other thing to realize, the tables designed in such a way they give you always area to the left. That's the key idea. That's how they designed. They give you areas from the left. I say, wait a second, Alex, what about areas from the right? Well, let's find area from the right. So I'm going to back to my textbook, and we'll try to do exercise number 13. Today is 13, so we'll do exercise number 13. How about that? So April 13th, already middle of April. How about that? The spring always goes pretty fast, so it's already middle of April. So probability that Z is greater than 2.33. See, how do you know, Alex, it's a Z? Well, if you read the blueprint above, the whole exercise it says find probability, and probability is always with parentheses. So what's we're trying to find, I put in the parentheses. And turns out it's not X score, but Z, because we're dealing with a standard normal distribution, and that's what they're saying here using continuous uniform. Well, they actually mean standard normal distribution. Oh, it's not here, it's here. Standard normal distribution. That stuff we don't need. This is something we don't worry about. So standard normal distribution. So the exercise is above, you skip, don't need it. I don't want to do every single little thing here. In fact, if somebody gets very interested, let me know. I can do this for you. It's pretty straightforward, but carries us away from the point. So anyways, number 13 says greater than 2.33. So number 2.33, if 0 is always in the middle, it will be greater, right, than 0. It is positive, so it's to the right from 0. So someplace here, and then I will make a picture, so the area to the right. Greater means to the right. So what should I do? Well, I should go back to the tables with standard normal distribution, and notice there is no positive number here, all negatives. And that's fine. I can move down to the next page that deals with positive. So the entire table comes from 2 pages, turns out. One with positive z-scores and the other with negative z-scores. How about that? So let me get the column with a place of hundreds, and looks like we have 300s or 0.03, and the row 2.3, so the row is here, and it's always like that. So column, that's why you need to know how many hundreds, and row. It's always the same when you deal with tables, so eventually you will get used to it. And the tables always give you areas from the left. You see from the left? Nice, Alex. Yeah, I see enough. Okay, so from the left, it's 9901. So please notice this area is almost 100%. It's 99%. So it should be pretty much everything under this curve. On the other side, and the question is, we don't need that. We need tail, the remaining portion, and what I do is subtract that area 99.17% from 1, because the whole thing is 1 or 100%. So I need to subtract 9901 from 1. I say, Alex, what about this point? Take it away so it doesn't bother me. So the sun appeared here. So I subtract 9901, just like that, and see what my answer equals to. And looks like the answer is going to be 0.0099. I say, oh, that's pretty low. That's less than 1%. Yes, it is, but we found it. They asked us to find it, and we did it. So if you need area on the other side, when it is greater than particular value, well, then you subtract from 1. That's the specific of dealing with those tables. Let's say, okay, Alex, what about if they want a 22 to find area in between? If they give me 2 values, well, looks like you're gonna need to find 2 areas and then decide what to do with those 2 areas. So if they want you to find the probability, which is area, so from now on, we're gonna have synonym of area, which is a probability, which is in between negative 118 and positive 2.15. Well, then you need to use tables twice. Again, 0 is always in the middle, so 2 is bigger than 0, 215. All right, and then negative 118 is smaller, so it is somewhere to the left. And then the area of this region that I must calculate, I need to do in 2 steps. So it looks like I need to locate 118 and 215. Well, since I'm already on the table, which is positive, so I'm going to go for the 2.15. So it looks like I need to select 5, right? 5 hundredths, because I always need to know the column and the row. So 0, 5 for 5 hundredths, and then 2.1, right? So we're in the positive page, 2.1. So if I trace the row until I reach the column, or you can go down from column until you get to the row, you will get some number on their intersection. You see it's under 0.5, and in the row that starts with 2.1. So that's how I get 2.15. Add 0.5 with 2.1, right? And the area it gives me will be all the way to the left. Table does not know what you need. It's already here for you, so it just traces area from the number all the way to the left, and this comes out to be 9842. Okay, I'll write it down. 9842, and then I'll need to use the tables again to be able to locate negative 118. Okay, so let me go up to negative page, negative z-scores, and I need negative 1.18. So let me scroll this. It's too much mess. Let me clean this mess. So I'm gonna just do a little bit of erasing. Don't want to stop cleaning everything. I need some of this. Let me just clean this. They have nice erasers. So I can almost done. So you get negative 1.1. Again, please notice the areas now with for negative z-scores, right? So I need to find 0, 8, right? The column 0.08, because again, we have 18, so 8 hundredths, and then 1.1. So minus 1.1 for the row is here, and they will meet each other right there. It is right here, and I got to look at the little tail to the left, the dots. So this region is 119.119 or 1190, same thing. And turns out I must subtract it from the bigger. So to find the area, it is always positive, so I need to subtract always the smaller from the larger, and that's how I will get my answer. So 2 will stay, and then there'll be 5. So borrow 1, 7 minus 1 is 6, and 1 minus 1 subtracted from 9 is 8. You can use calculators to subtract if you want. So I believe this is 0.8652. That's how we found another area. And again, in a calculus class, they usually have area under the curve. Well, let me show you what they actually do there. If someone already took business calculus, for example, I'm sure you saw that procedure of integration. And they actually provide us here in the beginning of this whole story, the actual equation of the curve of that normal distribution. So I saw it somewhere. So here's the equation. We say, what is this? Well, that's a standard normal distribution. If you put for standard deviation here, number 1, and for mean 0. So it'll be just x squared. And that's dealing with number pi. So it is really not much fun, and that's power of e. So that's the equation of that curve. And then when you take integrals, so you have to put left end and the right end. So if you would put negative 118 for the left end, the lower limit, and 215 for the upper limit, and then you need to integrate, find the antiderivative, so use substitutions. And that's something that we don't need to do at all, because it carries us away into calculus area, and it'll take me a while to show you how we do all that, right? But it is possible. But again, what they did is they calculated all of these areas themselves, well, using computer, I guess, and put the numbers in the tables. So now we're using the tables. So that way you don't need to know calculus to do probability, because usually probability theory is what we learn after we took the, so it's needs to be going in the 4-year school for that. And the point of me saying all that is that some students can appreciate mathematics. So the reasons why we're using tables is because somebody did hard work to enable us to do it without any using of calculus, learning the calculus. But it is not that simple, the bottom line. It is not that simple at all. So anyways, so we're not gonna do it like that ever, and there's no point to waste time. So what we're gonna enjoy is section 5.2. I think it's a nice little introduction. I want to stop at this stage because I know it's too much already with these tables, so don't want to stress you out, because from now on, we're going to use tables on daily basis. And little by little, I'm sure you will get used to it and then start to enjoy it. And that's my goal. So we'll look more at these tables and more, and eventually we'll feel very comfortable. Because I'm sure when you see it first time in your life, you're wondering what is this, and it's totally not pleasant. But no worries, we will do it again and again, and eventually we'll say, oh yeah, it's pretty straightforward. And this is the whole point. So I'm gonna stop recording for today. So I think it's too much for the quiz, but next time I will do more, and I will ask you to use tables as well for one little exercise. All right.